Hi, welcome back to Math 112. Let's take a few minutes here and finish up section 7.2. So this is the second of two videos related to section 7.2. And I'm going to present and show you the product to sum and sum to product identities. So let's start with the product to sum identities. And these are identities, rules that let us take the sine of one angle and multiply by the sine of another angle and express that as the sum of a sine and a cosine, a sine and a sine. We've got similar rules we've got rules for sine alpha times sine beta. We've got a rule for sine alpha times sine beta and cosine alpha times cosine beta. Here are your cues. Sine times sine is equal to sine of the sum plus the sine of the difference divided by 2. Sine times sine is the cosine of the difference minus the cosine of the sum divided by 2. And cosine times cosine is the cosine of the sum plus the cosine of the difference divided by 2. These are going to take practice, and it's going to be work, but you do need to memorize them. There is a reference sheet posted on the course website that you can download and use during homework. So I know we're amassing a lot of identities that can be difficult to remember. And some of you may be wondering, why are we doing this? Well, part of it's because we can. To be honest, periodic functions are a lot of fun for people who are interested in these things. The other thing is that periodic functions can be used in a lot of the higher order math to replace complex expressions that we don't know how to handle, but we know how to handle the periodic functions. And one of the ways we can handle the periodic functions, the sine and the cosine, is through these identities. So what we're doing is we're looking at different ways to combine the periodic functions together. These are just things we need to memorize and be able to use. And yes, I know that when you're done with this class, you will probably not remember them a year from now when you might need them, but that's okay. I want you to have seen them. I want you to memorize them, because then when you do need them, you'll be able to at least say, oh, wait, I remember there's a way to do this. And then you can go find your reference sheet and look it up. For this class, you need to memorize these. It's actually kind of part of the outcomes of the class is that you know these identities, at least for the duration of this term. So let's take a look at how we would utilize these. We're going to write the sine of 4x times the cosine of 4x as a sum. So we're going to use our identity that tells us that the sine of one angle multiplied by the cosine of another angle is equal to 1/2 of the sine of the sum of the angles plus the sine of the difference of the angles. So that means that the sine of 4x multiplied by the cosine of 3x is going to equal 1/2 of the sine of 4x plus 3x plus the sine of 4x minus 3x, which is equal to 1/2 of the sine of 7x plus sine x, and we'll distribute and be done. So 1/2 sine 7x plus 1/2 sine x. Okay, that's one way to apply these identities. Here's another. Suppose we want the exact, so not calculator value, of sine 75 degrees times sine 15 degrees. All right, so let's use our identity. This says that the sine of one angle multiplied by the sine of another angle is equal to negative 1/2 times the cosine of the sum of that angle, sum of the angles minus the cosine of the difference of the angles. So that means that the sine of 75 degrees times the sine of 15 degrees is equal to negative 1/2 times the cosine of 75 plus 15 minus the cosine of 75 minus 15 degrees. So that's equal to negative 1/2 times the cosine of 90 degrees, we like that one, minus the cosine of 60 degrees, we like that too. All right, cosine of 90 degrees is 0. Cosine of 60 degrees, 1/2. So we've got negative 1/2 times negative 1/2. So this is just 1/4. Right. This one turned out to be one you could get from your calculator, but if it were something like square root 6/2, you couldn't. All right, those were the product to sum identities. We started with a product and wrote it as a sum. And there's a mistake on this slide. This one, the sine times sine, there needs to be a negative right here. That needs to be a negative 1/2. So correct your notes. It's correct in the textbook. This was just my mistake. All right, so now let's go the other way. Let's start with a sum and write it as a product. So we've got sine u plus sine v, so the sine of one angle plus the sine of another angle, equals 2 times the sine of the sum of the angles divided by 2, multiplied by the cosine of the angles, cosine of the difference of the angles divided by 2. This is a pattern you'll see repeated. We'll have sine plus sine or cosine, and then we'll have sine times cosine. And one of the arguments will be the sum of the angles divided by 2. The other one will be the difference of the angles divided by 2. So sine minus sine is 2 sine of the half of the difference multiplied by cosine of half of the sum. Cosine plus cosine is 2 times the cosine of half of the sum multiplied by the cosine of half of the difference. Cosine minus cosine is equal to just checking that, yeah, okay. Negative 2 times the sine of half of the sum times the sine of half of the difference. However you work these into your head is up to you. Different people have different techniques. I use sum and difference. So I'll say sine plus sine is 2 times the sine of half of the sum times the cosine of half of the difference. That works for me. Whatever works for you is what you should do. But either way, you do need to commit these to memory. Okay. And I'm pretty sure these are included in that flashcard deck that's on the course homepage. Okay, so let's use this. We have been told that the sine of an angle plus the sine of another angle divided by the cosine of the first angle plus the cosine of the second angle is actually the same thing as the tangent of half of the sum of the angles. Well, this would be easier to use if we can prove to ourselves that that's true, so let's figure it out. We could start with either side, but we don't know how to handle the what we have in here. We could maybe use our sum to product, but let's not. Let's start with the left-hand side and simplify it down to the right-hand side. In general, I will start with the more complex looking expression and simplify it to the simpler. So we're going to start with the left-hand side. So let's start with the numerator. The numerator is sine x plus sine y. We can use our sum to product identity and write that as 2 times the sine of x plus y over 2. Ooh, I'm liking that. Times the cosine of x minus y over 2. Now let's see what happens when I write the denominator as a product. So cosine x plus cosine y is going to be 2 times the cosine of half of the sum times the cosine of half of the difference. All right, so now my left-hand side, put it all together. Sine x plus sine y divided by cosine x plus cosine y equals 2 times the sine of x plus y over 2 times the cosine of x minus y over 2 divided by 2 times the cosine of x plus y over 2 times the cosine of x minus y over 2. Hey, this is looking promising. Look what happens. So this is all a product and this is all a product. So I can cancel, as long as I'm a little careful. I can cancel the 2 and the 2. And this cosine matches that cosine, so we can cancel that. And we're left with the sine of an angle divided by the cosine of that angle. Sine divided by cosine is, yeah, that's tangent. And look at there, it's true. The sine of an angle plus the sine of another angle. So the sum of the sines of two angles divided by the sum of the cosines of two angles is equal to the tangent of half of the sum of the angles. Good work. Okay, let's do another application. We want to evaluate the sine of 75 degrees plus the sine of 165. We're going to use our sine plus sine identity to remember that that is 2 times the sine of half of the sum times the cosine of half of the difference. So this will be, so the sine of 75 degrees plus the sine of 165 degrees is equal to 2 times the sine of 75 plus 165 divided by 2 multiplied by the cosine of 75 minus 165 divided by 2 degrees. So that is 2 times the sine of 75 plus 165 is 240, I think. Let's check that. $165 plus 75 is, yes, 240 divided by 2 is 120 degrees multiplied by the cosine of 75 minus 165 is negative 90. Yes, divided by 2 is negative 45 degrees. We can consult our unit circle and find that the sine of 120 degrees is the square root of 3 over 2. And that the cosine of negative 45 degrees is the square root of 2 over 2. This 2 cancels with that 2, and we're just left with the square root of 6 over 2. Okay. If you're having questions with any of this, having troubles with how I'm doing these applications of these identities, please come to one of the study sessions or get a hold of me via email. One more and then we'll be done with this section. Let's solve this equation. The cosine of x plus the cosine of 3x equals the cosine of 2x. Nifty. So, first thing we need to do is get rid of this plus sign because we really can't do much with this. So let's use our identity and rewrite the left-hand side as 2 times the cosine of the sum divided by 2 times the cosine of the difference. Let's do a little work here. This is 2 cosine 2x. And this next one will be cosine of negative x. Remember that cosine is an even function, so the cosine of negative x is equal to the cosine of x. I'm going to rewrite that as 2 times the cosine of 2x times the cosine of x. Ooh, I like the cosine 2x. So now my equation is 2 times the cosine of 2x times the cosine of x equals cosine of 2x. Now be careful here. We want to treat this as a polynomial sort of equation, so I'm going to subtract cosine 2x from both sides. So I end up with 2 times the cosine of 2x times the cosine of x minus the cosine of 2x equals 0. Okay, I've got a cosine 2x and a cosine 2x. Those are going to be the same number. So let's factor that out. So that'll give us a cosine of 2x multiplied by, what's going to be left here is 2 cosine x minus 1 equals 0. So now we can treat this exactly as a factored polynomial and realize that cosine of 2x equals 0, or 2 cosine x minus 1 equals 0, which means we're looking for places where 2x equals the inverse cosine of 0. All right, so angles that have cosine of 0 are pi over 2 and 3 pi over 2 and 5 pi over 2 and 7 pi over 2, right? Got to divide all those by 4, and we end up with x equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So these are all actually, we could write this as pi over 4 plus k times pi over 2, where k is any integer. So pi over 4 plus k times pi over 2. I'll write that up here because I'm out of space. So one part of our solution is x equals pi over 4 plus k times pi over 2, and k is an integer, any integer. Okay, that comes from this root. Now let's work on this one. This one tells us that the cosine of x is going to equal 1/2. All right, angles whose cosine is 1/2 are pi over 3, five pi over 3, 7 pi over 3, 11 pi over 3. So each time we add 4 pi over 3. So the other half would be pi over 3 plus k times 4 pi. Actually, do we add 4 pi over 3? We do, where k is any integer. So this is my solution set. I got there because I had my sum to product identity. All right, that's it for this section. Check back again soon for a section 7.3 video, and do good math. I'll talk to you all again soon.